With the current passage of Comet Borisov through the solar system, studies of that object, the second interstellar object to be identified, are proving that despite being from somewhere else in the galaxy, it's not that different from a run-of-the-mill solar system comet. This deepens two mysteries, however. The first is why we haven't seen an interstellar comet before. Scientists have been studying and tracking the orbits of comets since the 18th century and Edmund Halley. Up until now, no comets were found to be on a hyperbolic trajectory, or were moving too fast to be bound to the sun. This led to some thinking that perhaps the interstellar medium somehow erodes comets, and they just don't have any volatiles left to flare up, and thus would be difficult to spot. Yet Borisov seems to be a normal comet forming a tail and a coma as normal comets do. So why haven't we seen an interstellar comet until now? Was it just the luck of the draw, or is Borisov actually the odd comet out, and interstellar comets usually don't flare up, making Borisov a rarity for how normal it is? But if Borisov is the norm for interstellar comets, something we'll know fairly quickly as there are many people looking to spot interstellar objects these days, then that serves to deepen the mystery of the first interstellar object ever found, Oumuamua. In a paper by Eric G. Flekkoy and colleagues linked below, they detail one possible but very bizarre scenario for the behavior of Oumuamua. The crux of the issue is that Oumuamua did not behave normally as it passed through the solar system. It accelerated on its way out, or perhaps more accurately, it didn't slow down enough on its way out. This would not be unheard of for a comet. Volatiles outgassing from a comet can give it a push. The problem is, no such outgassing was seen with Oumuamua. So it does not appear to have been a comet. That leaves radiation pressure as an option, but Oumuamua would have had to have been very thin and flat for this to be the case. And Oumuamua was sufficiently strange in its overall behavior that the idea that it might be an alien light sail was floated. In this new paper, however, there is now another option, that Oumuamua is more like a giant snowflake of sorts than a light sail. To come to the conclusion that Oumuamua is being pushed by sunlight, a density has to be assumed. To do this, they assume that it's roughly of a normal density, like ice or rock. This paper takes the opposite approach and shows that Oumuamua may not be dense at all, ridiculously so, far less dense than air. It would not really be a solid object, but it may not have to be. The paper details another option. If a star system that's very young and still sports a disk of material around it, it may be that it could form an object like this. In areas of that disk that are very far out, grains of dust and ice can form what's called a fractal. Such objects can be mostly empty space and can have just the kind of low densities that would be needed to be the case for Oumuamua. Modeling of fractals in star systems backs this up, showing that they can grow to the size of Oumuamua. But there would be restrictions here. The star system of origin would likely need to be fairly close by, and would have to be a young star with a debris disk. This probably isn't a very common thing, so we may never see another object like Oumuamua, and the debate over just what it was is likely going to remain open for some time. Thanks for listening. I am futurist and science fiction author John Michael Gautier, currently wondering if we will see more Oumuamuas and if we're currently experiencing an interstellar snowstorm of sorts. As if regular Earth snowstorms weren't enough. Gee, thanks, universe. Just one more thing to worry about, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.